Welcome to Brain Vision.
Okay, so we're doing chapter 37, problem 98. So it says, imagine a free particle of mass m bouncing back and forth between two perfectly reflecting walls separated by a distance L. So we have walls here separated by distance L, and we have a mass m that's bouncing back and forth. Imagine that the two oppositely directed matter waves associated with this particle interfere to create a standing wave with a node at each of the walls. Show that the ground state, first harmonic, and the first excited state have non-relativistic kinetic energies of these values. Okay, so for standing matter waves, there are nodes at two walls, what we want to do. So for the ground state, our wave is going to look like this, and for the excited state, our wave is going to look like this, such that in the first excited state, which I'll put here, L is equal to 1/2 of the wavelength. So if the wavelength is 1/2, or if 1/2 the wavelength is L, wavelength is 2L, then we can figure out the momentum here is h over 2L, such that kinetic energy is p squared over 2m. This now is h squared over 8m L squared. And that is exactly what we wanted to show for the first case. So now for the second harmonic, drawing like this, we see that one whole wavelength equals L. So if wavelength equals L, then we can go back to the kinetic energy equation of p squared over 2m. And this just becomes p squared over 2m L squared. So I don't know why that says p squared there. That should definitely be an h squared. Let me just erase this guy. H squared and L squared. This is for the first harmonic, this is for the second harmonic. Cool. That's it for this problem.